It's a real honor to give the 2013 Picard Lecture. So thank you for establishing the lecture and establishing the Health Law Institute. I didn't hesitate when Tim Caulfield invited me because the reputation of the Health Law Institute reaches pretty far, all the way to North Carolina and beyond. And we know of the work that goes on here and admire it. So I was excited to have a chance to come up and rub shoulders with my colleagues and talk about some of the research that I've been doing over the last few years. In 1990, which is already 23 years ago, so a lifetime for many of my students, Patricia Baird, a geneticist at UBC, struck a note that turned out to be prophetic. And she wrote a paper that was something of a manifesto in the journal Perspectives in Biology and Medicine, titled Genetics and Healthcare, a Paradigm Shift, echoing Thomas Kuhn's famous work that most of us read as undergraduates, The Structure of Scientific Revolutions, and the ways in which science moves on through paradigm shifts. She said, we're about to have one in health science, and that is the shift that genomics is going to bring. We need to see our own genetic individuality as a potential origin of disease, she said. Stop focusing on those external toxins and pathogens and environmental insults. Start focusing on what we bring to the table as patients, our own genetic endowments. We're all different. We're all genetically unique, which means our risk for disease is different from one another. Progress depends on realizing this and applying that knowledge to prevention. Well, she said that at an interesting cusp in the history of science, in the history of genomics. Right at 1990, after 40 years of slow progress in medical genetics, unraveling the genetic code, beginning to understand where genes are located on chromosomes, and just at that moment, the launch of the Human Genome Project, a systematic attempt to map all our chromosomes and isolate the locations, the loci that code for all our proteins. The curve of progress goes exponential at that point because the Human Genome Project came in on time and under budget with a complete sequence of the human genome by 2003. And now Francis Collins, the head of NIH, in his book, his manifesto for the future, echoes Patricia Baird almost word for word. We're on the leading edge of a true revolution in medicine, one that promises to transform the traditional one-size-fits-all approach to a much more powerful strategy, considers each individual as unique and having special characteristics that guide an approach to staying healthy. I don't think either Francis or Patricia may have actually read Thomas Kuhn too carefully, because you know, in The Structure of Scientific Revolutions, Kuhn is agnostic about whether the change between paradigms should count as progress. It's just change from his point of view. But nevertheless, in the popular mind, in the scientific mind, paradigm shifting and revolution has become the key metaphor for dramatic progress in science. And that's how they're using it. So what's this revolution pointing to? Well, it's right there in the title of his book, DNA and the Revolution in Personalized Medicine. That's what the Human Genome Project's going to bring us. That's what the paradigm shift is going to bring us. It's a little bit of a tangent, but when you think back on Patricia Baird's definition and Francis's description, we need to look at our own individuality as the source of human disease. Strikingly Protestant, right? Original sin. We're all born sick in various ways, and we need to quit focusing on germs and toxins and look to our own brokenness as the metaphor, as the source of genetic knowledge. And I like these images. The first one is the image NIH uses over and over again. You probably saw it in grammar school, some of you, for DNA in the genome, and it always struck me as looking an awful lot like the alien bursting from the chest of a poor person in the Ridley Scott Alien movies. And it's evoked by this Dartmouth Medicine cover, which does put this very much in a biblical context, right? The scientists, Adam and Eve, nakedness no longer symbolizes innocence, but white coats does, are about to eat from the tree of knowledge and don't seem oblivious to the fact that the genome might bite back. So looking at my own internal constitution as a source of disease, that doesn't sound very attractive. We need to package this in a way that's going to make it palatable. And personalized healthcare was the rubric that emerged only in the 2000s as the preferred label for this enterprise. What's so great about personalized medicine? In the literature, there's a mantra, repetition of virtues for personalized medicine, and they all start with P. So it's a promotion through a plethora of positive Ps. It's personalized healthcare promises to be predictive, preventive, and preemptive, with the potential to transform healthcare into a patient-centric healthcare system. In fact, Leroy Hood in Seattle has gone so far as to suggest that we change the name, have a shorthand, and simply call it P4 medicine for its virtues of being predictive, preventive, personalized, and participatory. These virtues are now the holy grail of translational genomic research under the rubric of personalized genomic medicine. And after the Genome Project was completed, the strategic planning for what comes next in genomic research is all aimed at reaching the bedside, translational research, reaching the bedside and achieving the revolution, bringing the paradigm shift to pass. So here's the Genome Institute's plan for charting a course. And in fact, over the last decade, they've been pursuing that course by moving into post-genome project genome research of various kinds, large-scale studies of human genetic variation and genomic functioning, all aimed at trying to achieve this goal of being able to tailor diagnoses and interventions to individual genetic constitutions. The Genome Institute's charting the course. The FDA's already paving the way. They've moved from charting a course to making the freeway in their report of this year, October 2013. And they again say it's define personalized medicine, what they're trying to build the infrastructure for as tailoring medical treatment to individual characteristics, needs, and preferences of each patient. Come back to that last. Every good movement needs a lobby, and personalized medicine has one in Washington, the Personalized Medicine Coalition, which likes to frame personalized medicine as a form of healthcare reform. Healthcare is expensive, reactive, inefficient. What we need is personalized, predictive, preventive, and participatory medicine. Personalized medicine. And they've had some success. There was a bill that was introduced in 2007 in the U.S. Congress to secure the promise of personalized medicine for all Americans, submitted by Senator Obama. And it didn't pass that year and really didn't get resubmitted the next year because he was on to other things. But in his role as our president, he's managed to pursue a lot of the goals without having to pass a bill through Congress. The Department of Health and Human Services launched a personalized medicine initiative in 2008, aiming to gear their research and infrastructure in this direction. The President's Council of Advisors on Science and Technology produced an important report laying out priorities for achieving the revolution. And in academic medical institutions, premier prestige institutions have all followed suit by already creating centers and programs for personalized medicine. Jumping the gun a little bit, since we don't really have that much to offer, right? But we can put a sign on the wall and promote our institutions by saying, yes, we have an institute or a center for personalized genetic health care. And the marketplace has not been slow to pick up on this, right? 23andMe, the most famous of these companies, says genetics is about to get personal. Don't panic, we're here to help. So we got interested in this phenomenon, trying to figure out what the promoters of personalized genomic medicine think they mean when they use that banner, and got some funding from NIH to launch a study of the ways in which the different advocates, promoters, and users of personalized genomic medicine understand the movement and understand its virtues. So we've been interviewing lots of different stakeholders that we've lumped into categories that are shown on this slide. The funders, the sponsors of this research, researchers themselves, in commercial developers, editorial boards of the new journals that have sprung up, various oversight groups like FDA, curriculum committees. Every medical school now seems to be reforming its curriculum in the direction of personalized genomic medicine. Medical centers, practices, and the patient-based organizations that have jumped on the bandwagon. They're interested in this too. And according to my sociological colleagues, what we're doing is studying the co-production of personalized genomic medicine as a boundary object in social space. Those of you who are science studies scholars can help us unpack what that could possibly mean. But what it means for me is that we are trying to get a handle on this enterprise even as it rolls out. We're only 2 years into the project, though, and it looked like, maybe it's over. In 2011, the National Academy of Sciences and the Institute of Medicine produced a report saying, yeah, let's not call it personalized genomic medicine. That's not working. Let's call it precision medicine. Viva precision medicine. You know, down with personalized medicine. It's what happens in revolutions. You get these kind of insurgency groups and counter-revolutions, all trying to get to the pure essence of the new movement. So Maynard Olson says, I think personalized medicine was perhaps a useful rubric to launch this activity, but it sends a misleading message, actually both to ourselves and the broader community. That's because the way they understand the movement, it's really to produce a more precise classification of disease into subgroups that were in past lumped together. Oh, that's interesting, and it's caught on. Already here on the Genome Institute's webpage, you start to see precision medicine as the term of art plugged in where you would have seen personalized medicine, like in the lecture ad at the bottom there. And so what I want to do today is tell you what we think is going on with this rebranding, with this labeling shift from personalized to precision, and draw out some of the ethical and social implications of the shift. To look ahead to the end, somewhat opaquely, what I'll suggest is that the field is already retreating from what was a pretty ragged individualism. We're used to rugged individuals in the West, in Canada and the US, rugged individualism. But it was kind of a ragged individualism to start with. But we're moving towards a more rugged forms of communitarianism in genomic research, of more authoritarian forms of genomics, for better or worse. One of the things we were interested in quizzing the promoters of personalized medicine about what they had in mind was the last virtue of that this was going to be participatory or empowering to patients to have this paradigm shift come to pass. It's the only virtue that doesn't seem to flow logically straight from the science. You know, yes, I can see how genomic testing could be predictive. You might use it for prevention. It's going to be precisely targeted to individuals, okay. But why would it necessarily empower them to take more control over their health care? It's a good question, but it's true that it's a cardinal virtue in all the promotional rhetoric for personalized genomic medicine. Personalized Medicine Coalition stresses this, that we're going to be engaging patients in lifestyle choices and active health maintenance. HHS in its initiative says going to have the effect of democratizing the process of healthcare itself by putting patients in charge. The main characteristic, says this commentator, is that we're moving to a co-diagnosis, co-care model in which the physician's seen as a colleague and advisor, just one of many input sources, and the patient becomes the active owner, administrator, and coordinator of his health care. All the academic institutions plug this into their rhetoric. The goal is to empower patients to understand their unique health care needs. The passive patient will be transformed into the engaged consumer. Even Francis, in his book, suggests that the success of personalized medicine can only come about if we each take responsibility for our health care. Health care providers can help, but they cannot drive your bus. So he wants you to read his book and learn the list of things you can do to take advantage of this for personal empowerment. And you'll be on the leading edge of the revolution. One of our interviewees said this: it's not just a buzzword. It has the ability to individualize and, I dare say, empower the person. If I say personalized medicine, it makes you kind of feel like you have your own private tailor. You're someone to be reckoned with. You're getting personalized medicine. You're an individual, and that's powerful. Interesting, exploitation of the connotations of personal and personalize that are in the background culturally. We use personal in lots of different ways, and this is picking up on a number of them. That this is personalized in the sense that it's private, it's under your control, it's a personal choice. And the consumer, the lay community, genetic disease organizations have picked up on that. Here's well, it just happened actually in September, Consumer Genetics Conference, Empowering Patients and Consumers with Advances in Genomics. And as the consumers get more, their voice grows stronger, the question they ask is, yeah, why let health professionals on your bus at all, much less driving it? Why not just go straight to the information itself via direct-to-consumer companies? And of course, the industry, the marketplace responds, offering all kinds of ways to know yourself genomically, and enjoys and exploits this empowerment rhetoric. Yes, that's why we're here. We're selling this to you in order to empower you. Getting to know your personal genome will empower you, etc. All right, well, why would the National Academy of Medicine back off? Why would they say, yeah, let's change our tune and go to precision rather than personalized? It has all that going for it. Everybody loves it. There are a few problems. First of all, it's not entirely revolutionary. The old school doctors responded almost immediately to say, what do you mean personalized medicine? Isn't that what we've always been doing? Tailoring our diagnoses and treatment to what we know about patients? You're just providing us another form of information, but yeah, the ethic, the paradigm is just regular medicine. So Edmund Pellegrino, as the chair of the President's Council on Bioethics, expressed that view in one report. Other leading physicians have. And David Altshuler at MIT, a member of that Academy panel, said, well, yeah, right. On one hand, personalized medicine is how medicine is practiced every day. And on the other hand, it's a complete fallacy to think that we're doing personalized medicine with genomics. Whoa. Well, what he means is it's not entirely accurate to think that we're individualizing diagnoses and treatments to individual people, because what genomics lets you do is to sort people into bins, risk groups. We know that people who carry this mutation don't respond as well to this medication, so we'll tailor our prescription to reflect that fact. But it's people who, which is a group of people, not an individual, and so it's not really that individualized. And patients are not going to be able to deal with this entirely by themselves without help, without expert help. For the genomic risk assessments that might come along, knowing my susceptibilities to future health risks, maybe I should stay out of certain environments or eat certain things, is going to soon run into the tsunami of data that we're getting about all our genomes, much of which is uncertain and probabilistic and is going to require expert help for us to understand it. So it's not really possible to get your genome readout and immediately see what you should be doing on your own. And for the other medically exciting form of genomic medicine, tailoring pharmaceuticals to genomic backgrounds, there may even be less room for patient choice. Now that I know you're not a good metabolizer for this drug, why would I even offer it to you? In the past, under uncertainty, this tradition of shared decision-making in medicine might lead me into a conversation with you to say, yeah, there are pros and cons of these two drugs, and you should have a voice in making the decision. Well, we've eliminated some uncertainty here, and now I can definitely prescribe this one for you, and don't even talk to me about the other one, because it's not going to be as good. That's a diminution of patient control, although maybe a beneficial one. And finally, as the social scientists like to point out, we've had the experience with lots of kinds of individual empowerment in our neoliberal society, and it's not entirely benign if it shifts responsibilities off society's shoulders and onto individuals. In this case, responsibilities for maintaining health. This is the sentiment that Francis is expressing when he says, you've got to take responsibility here. We can't drive your bus. You've got to know your genetic vulnerabilities and avoid the insults that would provoke them. It's essential you upgrade your knowledge base periodically. In the commercial sector as well, we believe that testing is about empowerment because your body and your health are ultimately your responsibility, not medicine's, not society's. And so we're here to help you take the reins. As Allison Harvey points out, the emphasis on an individual empowerment often disguises the fact that we're pushing the individualization of responsibility for health one step further. Apart from increasing the burden of individual responsibility and the blame for poor health, it's questionable how free and independent individual choices in this context could possibly be. And then there's this little aphorism from one of our Republican congressmen. Maybe I'll create a vocabulary primer. For example, take empower. Empower means cut them off, you're on your own. Eek. Well, that's not the kind of empowerment, I hope, that the genomic medicine folk had in mind. But it does echo the sentiments of this sort, a now famous statement by an insurance company executive trying to set the record straight about whether or how insurance companies might use genetic information. It says it's not for profit, it's to respect the wishes of our other policyholders. As harsh as it sounds, in an egalitarian society, solidarity stops at a negative genetic test. If I know I don't carry your risky mutation, why should I pay for the downstream costs if we can exclude you from the pool in advance? Given that it's not very accurate to say that we're personalizing medicine, and it runs into these downstream difficulties, why should we promote it as a cardinal virtue? We have a paper in the Hastings Center report of last year. We try to unpack this in detail from our data, pulling out 3 themes that the stakeholders gave us about why empowerment is an important note to hit. First, they say it's kind of a virtue of necessity. If, in fact, the genomic revolution is going to give people healthcare benefits on the side of genomic risk assessment and predictive testing for your downstream susceptibilities, most of those things have no therapeutic response available, except for you to avoid danger. So it really is only the patient who can modify their lifestyle to avoid the risks that we might predict. We have no preventive measures yet to prescribe. Another less common theme amongst the promoters is this is a moral stand against medical paternalism. We really do think that patients ought to be making decisions about their own health care. And a third theme that comes out is we need to get patients involved and empowered and invested because we need their support on Capitol Hill to promote the revolution. So I won't go through all these quotes. Thomas Gett's book is a great touchstone for the anti-paternalistic line. Thinks designated physicians as gatekeepers for genetic information isn't just disempowering. It reflects a persistent paternalistic streak that reflects a lack of faith in the ever more empowered patient. And then these folks saying we need their support. Well, rush through that part because I want to then tell you about what happens next, and that is the move to precision. The FDA in their report acknowledges personalized medicine isn't new. The practice of medicine has always been about treating each individual patient. What's new is that paradigmatic developments, oh there it is, the revolution, in science and technology offer new promise for developing targeted therapeutics and predicting who will respond to medical therapy and who will suffer ill effects. So it's shifting to the pharmacogenomic side of personalized medicine, not so much giving you downstream risk information that you can deal with by adjusting your lifestyle, and instead focusing on whether or not you're a good candidate for a particular drug. And in lots of the hospital statements about it, you see this kind of shift in the fine print, is that personalized genomic medicine will allow us, the healthcare professionals, to customize your treatment to what works best for you. So your physician can treat you with greater precision, fewer side effects, and better results. As the FDA says, in our current scheme, clinicians have no choice. Not patients. Clinicians have no choice but to follow a less than optimal approach. And the goal is to streamline clinical decision-making on your behalf by figuring out which drugs will do best for which patients. Even as early as 2008, one of the things that prompted this rebranding is the President's Council report, which kind of caved to the rhetoric and said, look, personalized medicine doesn't literally mean the creation of drugs or medical devices that are unique to a patient, but rather the ability to classify individuals into subpopulations that differ in their susceptibility to a particular disease or a response to a specific treatment. In the UK, they have bought into personalized medicine, but there for a while was a strong contender for an alternative label, and that was stratified medicine. Because their point was, look, having a unique medicine for every individual, for every disease, is not practical. It's not practical from a research perspective or from a pharmaceutical or diagnostic perspective. First step to improving healthcare is to identify what these subgroups look like, how to cluster individuals within a group, and manage the behavior in terms of a clinical response. If we can't get to treating patients in groups, then the hope of driving even further into a personalized medication is going to be well within our reach. So stratification puts it pretty nicely. You're trying to stratify risks within a population and plug patients into their particular risk bin. I don't know, stratified medicine just isn't going to fly very well on this side of the Atlantic. It has a kind of hierarchical class-based connotation, I think, that, oh, no, we don't want to be stratified into some hierarchy. We want personalized medicine here on this side of the Atlantic. But that's essentially what the IOM was advocating we do to reform our thinking about genomic medicine. They came up with precision medicine as an alternative. It's again about prediction, prevention, and personalization in the sense that you're individualizing people's therapies, or rather binning people's therapies into different risk categories. But the fourth P of participatory drops out. Nothing particular there for empowerment or patient-centered participation. The literature is all agog. Now we're moving towards precision medicine, preparing for precision medicine, and wondering what's in a name. Why did we call it personalized medicine in the first place? Industry following suit, moving from shotgun medicine, the bad old kind where you tried to treat everybody with the same dosage and just hope that it worked, to precision medicine. UCSF is a forerunner of this new rebranding movement, and I think this illustrative scenario they paint here is just great for making my point anyway. What is precision medicine? Imagine a time you could have a simple blood test on your way to the doctor's office and arrive at the appointment to find your doctor fully prepared with a diagnosis. Imagine that the ideal medication would already be identified based on your genetic makeup, perfectly formulated to avoid side effects for which you are susceptible. In other words, imagine if you never had to have a conversation with your doctor at all. You don't have to be part of this. It's almost 180 degrees away from what the language of participatory, collaborative, shared decision-making with which this movement began. So what are the ethical implications of precision medicine, of this brand? Well, we know what precision equipment is. Precision is a modifier, often signifies technical complexity and rigorous measurements that require expertise. Who runs precision equipment? Well, trained experts run precision equipment, not lay people. So right from the get-go, you're not reading yourself as a patient into the label of precision medicine. And in fact, along with this rebranding, it's come a resurgence in the literature of assertions of authority by the medical profession to be involved as gatekeepers of genomic information. Mostly it's in reaction to the Thomas Getts of the world and to the direct-to-consumer marketing sector. The medical establishment says, whoa, 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 we just can't have people being blown away by this tidal wave of data and confused, and they're just going to bring it to us for interpretation anyway. So there's an indispensable role for professional medical judgment in this business. It's not about patient empowerment. It's about, well, physician empowerment. I'll be better equipped to deal with your problems. That's interesting. And it got a lot more interesting this spring and summer when the American College of Medical Genetics released a report of recommendations about what clinicians should look for whenever they have a DNA sequencing machine warmed up on behalf of a particular patient. They recommended a list of 57 variants, 57 genes that should be sequenced whenever diagnostic sequencing is done. So if you're coming in to solve a medical diagnostic mystery by having your genome sequenced, or looking for a particular risk, what's my risk for breast cancer, as long as they've got the sequencing machine going, they're instructed to look at these 57 loci to see what your status is, on the grounds that these loci, mutations in these loci, all indicate high risk for severe disease, which we can do something about if we know it. So kind of like the rationale for newborn genetic screening. It's something we could do, we could learn easily, do something about for the patient's good. And like newborn screening, they suggest this should be done regardless of whether the patient's particularly interested in it or not, but simply out of the fiduciary duty of the doctor to look out for the best interests of their patients. So this has created a kind of firestorm within bioethics and health law, and even inside genomics, because medical genetics in the old style has always been proud of the fact that it's the most patient-centered of medical specialties. It only counsels its clients non-directively about their genetic risks, and only when their clients want to know, because they sure have a right not to know if they don't want to. All that rhetoric and pages and pages of literature defending that ethic of patient-centered, shared decision-making, rights to know and not to know, now being put aside by these recommendations because of the shift to a more paternalistic point of view. And of course, the commercial sector is happy to comply. Actually, a lot of the companies now have shifted from direct-to-consumer marketing to direct-to-physician marketing. And they're already saying, okay, for any samples arriving at our commercial lab after May 1st, we'll be following the recently released recommendations and getting back to you with the full gamut of results. So that's one trend I'm going to point to as the ragged, as the individualism of personalized medicine begins to fray back in the direction of more physician expertise. The other trend I want to point to is what comes out of what we're going to use to calibrate this precision equipment. What are the lenses that we want to look through in deciding what people's individual risks might be? And as this paper from the CDC suggests, it's all about placing individuals in populations, because it's the variations between different human subgroups that we're interested in, and human subgroups and human populations, well, what's the difference? So comparative population genomics has become the lens through which translational genomic research is moving, trying to identify biological differences between human groups in order to get clues about why some people do better on some drugs than others. One informant said, the hope here is that we'll be able to subcategorize people into ever smaller groups that can be more targeted in terms of how a diagnosis is done. The day will never come when each individual has something specifically done for them, but I think these groups or subgroups will get increasingly smaller as we learn and have a higher resolution of genetic information. Now, these are risk groups. They don't necessarily have to correspond with races or social groups or ethnicities. But in fact, for lots of reasons, good and bad, we tend to frame our comparative populational research in social categories, peoples, ethnic groups. And so the siblings and progeny of the Human Genome Project that have pushed down this road, trying to get an ever finer grained map of human genetic diversity, tend to be framed in terms of either continents of origin. The International Haplotype Map simply followed the color lines of American racism, red and yellow, black and white, to provide a global view of human diversity, or particular self-identified ethnic groups and social communities. Unsurprisingly then, you do get group-focused medicine out of that kind of research. The best example in the US is the FDA's approval of a particular medication for heart disease, specifically approved for use in African Americans, whatever that might mean, given what we know about the ancestry of most Americans of African descent. As a result, while there are those who are in the trenches keep showing that using socially identified categories and trying as a lens to create genetic populations doesn't work, like this study suggesting that as a consequence of these complementary levels of heterogeneity, group labels offered no guidance at the individual level, despite the scientific work that continues to show that, and despite Francis's aspiration, his wish, that we've got to move as swiftly as possible towards the identification of individual risk factors and get beyond racial profiling in medicine, most of the research still carries this flavor. In the wake of the haplotype map with its 4 colors, different strategies have been tried. And one strategy has been to say, right, it doesn't matter if we get one of each kind around the world. We just need to study genetic diversity where it is widest and deepest. Amsterdam Airport. Train platform in Grand Central Station in New York. You know, you get great snapshots of global human diversity going to those places. But if on a continental basis, the continent of Africa, that's where we know there's the most human genetic diversity. African populations carry the oldest, most diverse set of human genes. So if we get a good map of genetic variation in Africa, well, we'll have the rest of the world. And that's it. We can avoid these kind of social categories and the issues they raise. So H3 Africa, a joint initiative of the Wellcome Trust in the UK and NIH, has been launched. Build capacity in Africa for African scientists to do the genetic survey of the continent. Not parachute science, not safari science by Americans and Europeans, but African science by and for Africans. Because the studies which they'll support will relate genetic variation in these populations to clinical findings and environmental information. It's key to informing strategies for prevention and treatment, both at the individual and population level, i.e. precision medicine. Worries in this direction. Well, some of the worries are that there are some risks to being involved, as representatives of human genetic diversity. We go to high-frequency populations because that's where variations are clearest to see, but may give the misimpression that particular variants, particular susceptibilities, particular reactions to drugs are unique to those groups, when in fact we don't expect that to be true, as those other genomic studies suggest. And of course, we have to worry about whether the benefits, any benefits of precision medicine that come out of these studies will get back to those groups. So here's a story about the Maasai Morans, who have a wonderful capacity to digest milk that many Northern Europeans would envy, and are lactose intolerance. And they, genomic researchers have found the variant that allows them to digest all that milk and patented it. Well, of course. Why? They say it actually to ensure that benefits go back to that community. If not patented, any commercial group could exploit it and no gains would go to the local communities. So Professor Sarah Tishkoff and Floyd Allen Reed at the University of Maryland patented the Moran's gene, which of course is not particularly useful bit of information for the Morans. They already have that mutation. Who is this information going to benefit if any therapeutic or preventive things are developed from it? Well, those of us who are lactose intolerant. Nevertheless, the world is quickly fragmenting into national genome projects and national efforts to capitalize on genomic variation research in order to capture the benefits of that research for their local populations. And in fact, the other complaint worries about inclusion, but complaints about exclusion. In the HapMap, there were many peoples around the world that were not included because of their continental approach. And they were, in the second wave of the HapMap, started to get included. South Asians, for example, or Mexican Americans, the San people of South Africa, started getting included not by going to those places and negotiating with the communities, but by soliciting samples from expatriate communities of those people in other places. So we went to LA to find Mexican Americans to collect the genes of indigenous American peoples. That in itself was kind of an end run around Native Americans and indigenous Canadians who had already opted out, already said, no thanks, we don't want to be part of this approach. We had to have red in the map somewhere, so we went to Mexico to try to sort it out from the mixed peoples down there. South Asians, we went to Houston to find a community of people from India. And for the San people, South Africa was getting awfully sticky about doing research with their indigenous peoples, so they went to Namibia, which had no national ethics, research ethics review, and plenty of San wandering the desert. The San story is brand new. It's just this last couple of years and has created quite a furor in South Africa for lots of reasons. One of which is the ways it simply reinforced stereotypes about the San people by suggesting that, oh look, the sequent variants found in their genomes reflect an adaptation to a foraging lifestyle. So the fact that they're homeless and foraging and nomadic, that's okay. We don't have to do anything particular for them. They're well adapted to their subsistence lifestyle. That's created an interest among the San peoples of Namibia, Botswana, and South Africa. They just had a big conference to pick up on something the Mexicans did in response to the HapMap's in run, which was to assert genomic sovereignty over their genomes. Mexico launched its own genomic diversity project in the wake of the HapMap, saying that what they want to do is analyze genomic diversity in the Mexican mestizo populations to develop genomic medicine in Mexico for Mexicans. And sure enough, in doing that, they discovered that genetically the Mexicans and indigenous populations are substantially different from the 3 other known human genetic subgroups, Africans, Caucasians, and Chinese, whose makeups were documented in the HapMap. And why was it being done? Well, for the same reasons we do all translational genomic research, to establish the comparability of Latino genotypes to others in the global search for health-related genes throughout humanity. Part of their Mexican genomic diversity project was to assert this claim to genomic sovereignty over their samples. Mexican-derived human genome data are property of Mexico's government, and we prohibit its collection, use, and export without prior government approval. This was picked up by the folks in India, who've also developed now legislation saying, right, and the same is true with us, no matter how diasporatic our peoples might be, we own their genes. And you have to come negotiate with us if you want to have access to them. Be like Ireland claiming the Irish Americans' genome, etc. So this is the first first warning flag I see in the literature about this rise of a kind of rugged communitarianism in genomic research governance. It's worked before in isolated communities that do have a sovereign status of their own, like indigenous Americans who claim a certain sovereignty over research and the use of their genes. Now we're taking it to a national level to say it's South Africa that owns its citizens' genes, it's Mexico that owns its citizens' genes. Genomic sovereignty is the capacity of a people, a country, or a nation to own, control, and access to and use of samples and knowledge emanating from genomic material. Wow. Jantina de Vries and Michael Pepper are South African academics who have a very nice article pointing out some of the confusions and social risks involved in a doctrine of genomic sovereignty. Of course, it ignores the mismatch between population boundaries and national borders, given the way in which people have migrated around the globe. The San don't just live in South Africa, after all. That's why Namibia was another place to go. It reinforces the view that our national populations correspond to some discrete human deems, genetic populations, which we don't believe, and expect genomic research to discredit, and ignores tensions between minority populations and nation states, relocates the exploitation problem from international to national context. Why shouldn't the San people within South Africa have sovereignty over their own genomes? Why is it the South African national government's business? Moreover, if you want to go with this property route, as genes as a natural resource of a country, just like it's diamonds, and claim sovereignty over them, then it creates a collective responsibility to cultivate that resource, to get the most out of it. So here's Rosamund Rhodes, an American bioethicist, who says it's time to recognize we all have a duty to chip in to genomic research on behalf of our society. These studies will require the development of sample bank repositories with the participation of tremendous numbers of subjects. To reap the rewards, broad public participation will be required. To the extent that any group abstains from participation, their members will be less able to share in the rewards precisely because their genetic samples are absent from the pool. I want to point out that any existing injustices can only be exacerbated by members of these groups refusing to participate in research. If your group doesn't participate in studies to assess health disparities, no one will know that health disparities of the sort that negatively affect you exist. So, maybe we need a new civic ethic of DNA donation in the name of solidarity with our people or our nation. We should all get on board and donate our genes to the genomic enterprise. Francis has suggested, Francis Collins at NIH, that in America we create a genetic service corps, kind of like AmeriCorps or the Peace Corps, but it's a charitable activity where you all sign up to become research subjects, donate your genes. And in Mexico, they framed their genome project as a national crusade to get out there and do it. Here's a song that's become popular in South Africa. First, they came for our bodies because we thought we had no souls, slavery. Then they came for our souls, missionaries, because they thought we were ignorant. Then they came for our knowledge because they thought we had secrets, plants and pharmaceuticals. Now they think our secrets are in our blood, so they've come back for our bodies again. Interesting, and it does sound like it could be an African song, but in fact it's a indigenous Mexican group, a slogan from the Zapotec community, protesting the Mexican National Genetic Diversity Project, protesting the crusade as something that they don't necessarily see in their interest. So what they're facing is this rising sense that maybe we have a civic duty to participate in this research. Individuals have an obligation out of solidarity not to hinder potentially beneficial research that costs them nothing and is no risk to them. That's the second form of rugged communitarianism that I see percolating up through the literature and through the research developments in translational genomic research. That's where I want to leave us, with those two things out on the table. The weakness, again, of personalized genomic medicine as a promissory label was that it promised too much, more than genomics could actually deliver. It can actually deliver increased patient empowerment and participation if, in fact, its main job is to find out a bewildering amount of information about you that will take an expert to interpret and use in tailoring healthcare decisions to you. And while precision making correctly takes the focus of genomic medicine off the patient, I like it in the sense that it really acknowledges the sort of reductionistic clarity of genome analysis. Yes, it's about precision more than empowerment. But in the process, it flags these two other emerging concerns. To the extent that it connotes precision equipment and privileges medical expertise, where the folks who were excited about the empowering aspects of personalized genomic medicine are not going to be too happy with this shift back into the hands of the doctors. And to the extent that it echoes other forms of precision in the back of our brains, like precision bombing, precision targeting, it targets human groups as key units of genomic analysis. It does encourage this socially risky form of essentialism of encouraging people to see their social groups as the units of genomic analysis and pushing all the kinds of obligations that come along with that. Fortunately, just to end on a more positive note, there are a lot of people watching this field and these trends, and you can join us. There's a new online organization called LC 2.0. LC was the acronym for the Ethical, Legal, and Social Implications Program at the U.S. Human Genome Project. LC 2.0 has gone global to create a network of researchers and scholars and policymakers who are interested in these developments. And in fact, for precision medicine to achieve its goals, for the revolution to come, even here in the West, we need the rest of the world. We need the rest of the world's DNA and its genomic information to have that high-resolution, fine-grained map of human variation. So here's the website, and it's a free-for-all. So come and join us. I think this sums it up. I've been using this cartoon since about 1992, but it continues to be very apropos. We finally finished the map. We just can't figure out how to fold it. And that's what we're still trying to do, trying to package the map in a way that it can be useful. If you've ever been barreling down the highway with a badly folded map, you know how dangerous that can be. So thank you.
Thank you. So now let's throw the floor open for questions.
Oh, I didn't even see these people sitting over here.
Over here. Please, if you could introduce yourself and then...
I'm Sherry Taylor. I'm a clinical molecular geneticist here at the U of A Hospital. We're just wondering about your thoughts on a couple of things that you see happening in the clinical realm. At Baylor College of Medicine, they have a pilot project to do whole genome sequencing on newborns.
Right.
And as well with non-invasive prenatal diagnosis, there's talk of being able to do whole genome screening of fetal DNA actually off maternal samples. So this gets into the idea that this obligation you were talking about, and as the technology becomes easier, there becomes then a moral obligation to take you up on having this testing.
Right.
And the reality of doing this in the clinical lab is actually far different than that. But you see this actually starting to happen.
Well, that's right. My example was a moral obligation to get involved in research, but there's also the kind of public health drumbeat in the background that we might have a moral obligation to test ourselves and our kids.
Yeah, and then you see, I guess with the conference we were just at the ASHG in Boston, people who actually undergo that testing actually then start making, getting diagnostic testing done at a far higher rate than people who didn't have it. So you look at the impact on insurance industry and healthcare system, the whole bit. The downstream impact has been huge. Whether there'll be pushback.
A lot of our teaching with our medical students still goes in the direction of trying to avoid unnecessary testing and screening, right? But this is pushing the other way, generating the incentive.
There seems to be a desire to also impose an evidence base on top of that,
Right.
right?
Right. Yeah, it's a whole other talk, but the other thing that's going on, of course, is rolling out of our increasingly cheap abilities to sequence entire human genomes and finding interesting places in which to do that. Like, well, we're already taking samples from newborns for newborn genetic testing. Why not do them? We could do it prenatally, give parents more information than they would ever want. We could do it after you die as a kind of time capsule, a legacy for your family. You have your genome sequenced and put on a disk, and your family can use it for future diagnostic exercises. All of those uses would fall within the scope of these ACMG recommendations that as long as you're sequencing someone's genome, be sure and look for these 57 mutations, which is going to increase that worry about, well, not just false positives and false negatives, but what you do with all the information once you have it.
Yeah, up here in Canada, there seems to be a trend to, one, wanting to keep everything very evidence-based, and two, putting more choice into this instead of the obligation of getting those 57
Right.
results back.
Good.
Yeah.
Hi, I'm Mike Walter. I'm the chair of Genetics here. So I really thoroughly enjoyed your talk. One of the things that is coming out for us from some of the issues associated with precision medicine or genomic medicine or whatever we like to call it,
Right.
is that there's trying to balance the rights of the individual who is getting tested. For us, the immediate question is, can they then say, this is my information, you can't share it? Because obviously this has profound implications for the rest of that person's family.
Right.
Because if one individual in a family has, say, Huntington's chorea, that means their family itself is at risk, and there are other individuals, and so you have to balance that individual's right with the rights of the rest of the family. And what you're talking about is, by extension, the rest of society, where we define society as a country or as a community. I think that that's something, it's a broader discussion, but this is where I think geneticists need some guidance here.
Right.
Not ethicists.
Well, but you do have a strong moral tradition within the specialty, and it's better articulated than a lot of specialties. And what you're describing, those issues of confidentiality within a family, are traditional ones for medical genetics, for genetic testing, and there the tradition has been, well, you take that confidentiality awfully seriously, right? And you might feel torn if there are known family members who are, by implication, at severe risk of a serious disease, which you could do something about. Then you're on the horns of a dilemma. But beyond that, there hasn't been so much discussion in the clinical genetics community about any obligations to go further with that information. And I think that's what's going to get pushed now with public health interests and other sorts of community interests in the information.
Eric, thanks for that excellent talk. So I have a two-part question. The first is about the culture of scientific and ethical inquiry and what your presentation says about that. So the question is, you showed a lot of very important people who seem to support this idea and who seem to promote this idea. Are there any skeptics left? And the second part of my question is about that old buzzword, gene-environment interaction, and what that has to do, what role does that play, if at all, in this whole thing?
Yeah, great questions. There are skeptics, lots of skeptics, but they're relatively quiet. When you talk to scientists in the lab, clinicians, even people who've put in their grant applications under the banner of personalized medicine, that's one thing we did. We looked at NIH grants that featured personalized medicine in their title of their project. So you go to the PIs and they say, well, yeah, I did that because that's a buzzword. But I'm pretty skeptical about the prospects of this revolution really reshaping the face of medicine. So there's an interesting disconnect there between the official rhetoric and the accepted knowledge in the community. What was the second part?
The gene environment.
Oh, yeah. And the environment is a piece of all these definitions of personalized medicine. They say we want to be able to tailor your drugs or your treatments to not only what we know about your genome, but what we know about your personal environment. But it's there in the definition and then never referred to again in most of the treatments, because the focus is this is about genomics and genetics. So in theory, having a fine-grained map of your environment would be just as important to personalizing your care as a fine-grained map of your genome. And everyone will admit that, but I think the research emphasis is not there.
And I'm Janet Spring, biological sciences. And that's like, to me, to sequence a newborn, I just kind of thought that's kind of a crazy thing to do, because it's all the microbes that are interacting with that newborn. So you're only getting maybe 1/10 of the data. So this is why, again, you know, to sequence an individual, ignoring the fact that they're carrying around 10 times as much DNA from bacteria and everything,
Great.
is kind of a nonsense number.
Yeah.
And then we had a sick child, and the same thing, the doctors kept looking for a genetic reason to write him off. And so to me, that was again a big, you know, an ethical issue. I could say, you can't write him off until we've looked at these other treatable options. And that was why I don't even get involved with the subsequent children having genetic testing, because it's too easy to say, I'm going to then take, because if you look far enough, you will find a deleterious gene. If you look far enough, you're going to find some reason to say, I won't treat the child. So that was just sort of my thought there, that don't talk about the individual without the bacteria.
That's a great point, and one of the things, of course, that keeps the genome research enterprise alive and well is that there are new things being learned all the time, and we're even as we're trying to develop applications for genomics, we're learning just how complicated the real story is, the epigenetic story, the gene environment story, and the microbiome is just a perfect example. The fact that actually the DNA and all those gut bacteria serve us a very useful function. And there, the microbiome folk, as you probably know, like to describe us as superorganisms genetically. We are colonies of primate lineage DNA, really just a small bit of primate lineage DNA, and then a lot of bacterial lineage DNA, all gamished together.
Well, I'm going to take Chairman's privilege and ask 2 questions.
Okay.
So, the first one is around whether you think genetics is going to ever be able to deliver the precise prediction of magnitude of benefit from intervention that's going to be required to make a genetic case for reimbursement. So as we're moving into an explicit reimbursement environment in palliative effectiveness research, it's not a direction of effect, it's a magnitude of effect that you have to demonstrate. Do you think genetics is ever going to be able to do that on an individual basis?
Right. To be able to say, given all that we know about your overlapping risk categories, because of what we know about other people in those categories, and given what we know about your environment, have we got the drug for you, and it's going to make a huge difference? Well, I don't know. It's hard to predict the future. Maybe actually our geneticists are the people to ask about that, just how potent this kind of information might be once we had all the right pieces in place. I mean, the excitement is that it could really be, but I don't.
Yeah, I mean, on an individual basis, if you're doing whole exomes or genomes, there are certainly published cases out there where it's made all the difference in the world. You have a child with an intractable condition that you find that particular genetic thing just for them that changes the course of their
Right.
So those monogenetic disorders.
Yeah, but if you look at
You went for a prevalent disorder.
If I'm trying to tailor my anti-cholesterol drug to my genomic endowment.
It's interesting, and there's some genetic counselors here as well that.
Over here?
I mean, over there.
Oh, I thought the geneticists all had to be sequestered on that side of the room.
That if you look at some of the advice, and you know, when you think about it, you think of everybody in this room is genetically flawed. We all have something. There's
Yeah.
no getting out of that.
That's the original sin.
Okay.
Because it is a flaw.
It is a flaw.
It's not a variation, it's a flaw.
Right.
You know, if you're trying to talk to ministries of health about this sort of thing, you know, they get cystic fibrosis, they get those single gene things. But when it comes down to trying to pile everything together, all these, something complicated like heart disease, you know, the basic advice we've all been given all the time is, you know, exercise. exercising, sleeping right, reducing stress,
Right.
all of those things, those are going to be the big, eating right, those will be the big players in your health. It really just, it doesn't matter, what else. We
Yeah.
always come back to that same advice. I think you probably agree, like you're helping some people about that. If you've got a strong history of something like breast cancer or whatever, that changes stuff. But for most of it, it's still that same advice gets you a long way.
And that's not terribly reimbursable, huh?
Well, no. Second question.
Okay.
You raised at the beginning, you raised the issue of preferences and individuals' choices. So how does that work with a situation where genetics is going to produce a risk equation that says you probably won't respond as much as another group of people?
Yeah.
How do we respect individuals' preferences to still have the treatment? On a probabilistic basis, can we respect their preferences and still take them out of treatment options? How does that work?
I think we can. I think we should still respect their choices. And traditionally, it's that element of uncertainty that's made it easy for physicians to justify giving the patient the right to make the final call. It's kind of a gambler's ethic. They're the ones that are putting up the stakes, so they should be able to call the roll of the dice. And as long as it's probabilistic, as long as there's uncertainties involved, we're still in that sphere. But as the uncertainties diminish, as more and more evidence mounts that this really is the choice for you, then I think physicians' obligations to prevent harm are going to, push them to be more directive and to try to manage or limit the patient's choices more. We still let patients refuse very obvious things that can save their lives in the clinical setting. So the ethics of treatment in medicine has dealt with this issue and come down on the side of patient autonomy. Even if you're going to die, you don't have to have this blood transfusion if you really don't want it. And we're just now beginning to talk about the same kind of ethic in the diagnostic sphere. Even if do I have a right to remain ignorant of my risks or choose to ignore my risks in going forward?
Yeah, I have a sense of where the ethics community is likely to sort of land on that.
Yeah, I think the ethics community, being kind of stodgy, is going to stick with this ethic of patient autonomy and respect for patients' wishes and shared decision-making. It seemed like a very much of an establishment kind of position, or a consensus position for a long time, but now it's beginning to look like a rear guard position as other forces press the issue in the other direction.
I'm a bit more skeptical on that point because we're beginning to see in similar contexts where, for example, issues around what we do with tissues that we store for research,
Yes.
and how we deal with patients or donors of those tissues when they haven't expressed specific preferences as to what to do with that tissue. There's a fairly sizable proportion of the ethics community that's beginning to say we need to move to this, what you describe as a rugged communitarianism model.
Oh yeah.
So
That's okay. That's true.
I mean,
That's true.
There's fewer ethicists now on the side of patient autonomy. I actually see ethics going to, let's just, donate your DNA and forget about it.
You get two ethicists in a room and you've got three opinions. So it's but you're right. You're right. There are plenty of people in the bioethics community that are like Rosman Rhodes, saying, let's just realize we all owe a duty to support the research enterprise. Yeah. I'm on the other side of that debate, but that's another talk too.
I just must say at this point, from a legal point of view, think of that great, I think, Australian judge, Justice Windear, who said, law is always behind medicine. I'll say science in the rear and limping slightly. But nevertheless, limping along.
Right.
Because these things for law are, imagine creating legislation to deal with any
No, right. Even
of this. Or case law.
case law or legislation, but even professional practices, professional policies, recommendations. There are lots of informal forms of governance and regulation that might be a little more tractable than law, but even those are lagging and limping.
Well,
All right.
we have no more business.
Thank you very much.